Okay, so let's talk about the least common multiple. And hopefully this again does make sense, or not make sense, but that you are somewhat familiar with this term. Least common multiple. So a multiple, it's the product of a number and any non-zero number, non-zero whole number. So I like to think shoes. So if I was to count by 2, so I have the number 2, the multiples of 2 are 2, 4, 6, 8, 10, and so on. Again, notice I'm not asking for a factor, not the greatest common factor, not what makes up the number 2. I'm looking for the multiples, so it's like by your counting. So a common multiple would be a multiple that is shared by 2 or more numbers. So let's use the numbers, let's say 2 and 8. So then 2 has multiples of 2, 4, 6, 8. 8 has multiples of 8. I'm actually going to do these little dots right here. 8 has multiples of 8. So I should put a 2 in here. Because that's 8 times 1. 8 times 2 is 16. But I don't need to go any further because here's my common multiple. And there will be others, but that's the least common multiple. Okay, so the least of the common multiples is what we call the LCM. So I did say I was going to show you 3 ways, but I think I'm only going to show you 2 by using our factors and our prime, listing the multiples, just like we listed our factors, listing the multiples, and then using that prime factorization. So here we go. The least of the common multiples is the LCM. You can do this. So here we go. The first way is by using a list. Okay, so we're just going to do our counting. 5, 10, 15. And we can do that. So let's list our multiples. Again, 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. And then you can go 20. 25, and so on. Okay, actually I'll go to 30, and then 35. Okay, now let's list our multiples of 6. So we have 6, it's our first one. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. As soon as I find a common multiple, I'm done. So my least common multiple is equal to 30. All right, let's look at 4 and 8. I think we already got that one, but let's just go ahead and show that. So 4, a common multiples. Again, all you're doing is you're counting. You want more shoes. So 4 times 1. 4 times 2 is 8. I'm already done. This one is an easy peasy. Again, as soon as you have a multiple that is in common, you're done. So your LCM is equal to 8. All right, and then let's take this next one, 12 and 16. So here we go. We have our multiples of 12. First one, we like our freebies because this is really saying 12 times 1. And then we do 12 times 2, which is 24. 12 times 3 is 36. Okay? And then 12 times 4 is 48. And I'm going to go ahead and do a few of the 16. Put your freebie down. 16 times 1, 16. 16 times 2, 32. 16 times 3, 48. Oh, we're already done. Now here's what I'm going to do. If you don't remember this, 16 times 2 is 32. That's okay. Go ahead and write it down. And then 16 times 3, why I got that so quickly is I knew that 3 times 6 was 18. And then I carry that 1, so get 48. Oh, look, I have something in common. So I'm done. My least common multiple. So the lowest of my common multiples is going to equal 48. All right, so listing is one way. The other way is by finding your prime factorization. Okay, so go ahead and pause the screen, make sure you write this down, and then I'll walk you through this example. So step 1, find the prime factorization of each number. Okay, so that's what I'm going to do. I'm going to make my factor trees. So I know that this is 2 times 2. Oh, I already got my monkeys. So my prime factorization is 2 times 2. And then I'll do a factor tree for 10. Oh, that one's easy too. 2 times 5. They're not all going to be that easy. 2 times 5. Okay, now circle the greatest power of every prime factor. Okay, now this is a key. The greatest power that appears in any of the prime factorizations. So remember, we're going to write this as 2 to the second power. Okay. So the greatest power between the 2 and the 2 squared is 2 squared. Okay. So 2 squared, that's the greatest power to the second power, because this is only to the first power. And then I also have a 5. So I have to multiply this. That's the greatest power because there's only one 5. If I had a 5 times 5 up here, that would be it as well. So my LCM is going to equal 2 squared times 5. 2 squared is 4. 4 times 5, and that gives me 20. So my LCM is 20. This one is, again, a hard one for students because, and just a reminder, that's multiplication, because they don't know how to identify the highest power. Okay, and you have to multiply each term. You make sure you get all the terms in there, but the one with the highest power. So again, usually you have a preferred way of doing things, and I prefer making a list of the multiples and doing my counting, but you can always use your prime factorization. Okay? And that'll always be a good way. It's just hard for a lot of students to identify the greatest power. Okay, so I think this was one other example. And so we have 1 and 5, right? Those are our prime numbers. And then 8 is going to be 2 and 4, and 2 and 2. Oh, here's all my monkeys. So again, this is 2 to the third power. And this is just 1 times 5. And then 12, I can break that down into 2 and 6. Then I'm going to break that down into 2 times 3. Here's all my monkeys. And I know I'm going fast, so make sure you pause it and write it down. So this is going to be 2 squared times 3. So then I circle the greatest power of every prime factor. Okay, so my LCM, I'm going to circle the greatest factor. Well, I only have 1 5, but that's a factor, so that has to be in there. I have 2 to the third, and I have a 2 to the second, but the highest power is going to be 2 to the third. And then I have a 3. Okay. So this is going to be your LCM. So let's go ahead and figure out what that is. 2 times 2 is 4. 4 times 2 is 8. Okay. So then it's going to be 5 times 8 times 3. So 5 times 8 is 40. 40 times 3 is 120. So my LCM is 120. So this one would take us a while to get to, and that's why using the prime factorization would be helpful. But you can still get there with the listing out. It would just take you a little bit longer. All right.